So we're ready to start the material for section 7.3 that's called the unit circle. But before we talk about the unit circle, we are going to talk about circles of any radius. We're going to look at the definition of the trigonometric functions based on a circle of radius r. This is not discussed in the textbook, and yet I think it's important. That's why we're going to work on it. And so all the material will be covered by the video content. And so let's go. So let's look at this definition. We need to set up a certain picture here. So I say let R be any positive number. R could be 5, 1,000. R could be 1/2. R could be 1. Consider a circle of radius r centered at 0, 0 in the xy plane. Let theta be an angle in standard position. So I've drawn the angle theta there in standard position. And let xy denote the point of intersection of the terminal side of theta with the circle. And in fact, the picture that I've drawn here is the situation when theta is an acute angle. And when we have an acute angle, we can actually draw a right triangle in this picture. So I can draw a line straight down from the point xy. So it's perpendicular with the x-axis. And let's see if we can describe the sides of this right triangle. This length from the point straight down to the x-axis is equal to the y-coordinate of the point. So y gives the length of that side. Along the base of the triangle, this distance is the same as the x-coordinate of the point, xy. And the hypotenuse of the right triangle, because this is a circle of radius r, the hypotenuse here, which extends from the center out to the circle, is a radius. So the length of the hypotenuse has to be r. And so we can write down sine of theta. Now we're going to base this on SOHCAHTOA, right? We have a right triangle in this picture. Sine of theta is opposite over hypotenuse, but in this picture, opposite over hypotenuse is y over r. Cosine theta is adjacent over hypotenuse. In this picture, that's x over r. And tangent theta is opposite over adjacent. That's going to be y over x. So these three formulas are super important. I'm going to put them on a yellow card. And this is actually step 2 in our development of the trigonometric functions. So remember from one of our first videos, I outlined 4 steps. And here we are, finally, at our second step. And these formulas have to be memorized, but I hope you see that if you kind of remember this picture and you remember SOHCAHTOA, it's easy to just generate these formulas because y over r is opposite over adjacent, x over r, is opposite over hypotenuse, x over r is adjacent over hypotenuse, and y over x is opposite over adjacent. But now this goes further, okay? So we're going to shuffle the pages a bit and move on to my next page here. One thing I want to point out, we will see this as we go through different kinds of problems, but different size circles, so different values of r, will give us the same ratio values for sine theta, cosine theta, and tan theta. So a large circle or a small circle will give us the same value. And really the reason is, if we use a larger circle, the triangle will get a different triangle, but it will be similar to the triangle in this picture. So for a given theta, all the triangles that you get are similar, so the ratios of the corresponding sides are proportional, and the ratios will come out the same. Also, we will use the formulas in the box that we just filled in to define the trigonometric functions for any angle with the terminal side in any quadrant, even when we cannot draw a right triangle. So this is really what's new here. We're extending trigonometry beyond right triangles to any angle at all. Any angle, positive, negative. Angles can be greater than 360 or anything at all. So for example, though, for right here, let's just suppose the terminal side of theta is in quadrant 2, and let's take a look at what the picture would look like. So I'm just gonna pick terminal side there. So here's my angle theta, so that's greater than 90 degrees. We have the point xy, where the terminal side intersects the circle of radius r. And now there's no right triangle because, you know, theta is greater than 90 degrees. A right triangle cannot have an angle that's greater than 90 degrees. So we're not going to draw a right triangle, but we can still say, in fact, we're going to define the sine of that angle theta to be the same thing I just wrote on the previous page. We're going to define it to be the y-coordinate of this point divided by the radius of the circle. And cosine of theta is the x-coordinate of this point divided by the radius of the circle. And tangent theta is going to be the y-coordinate of that point divided by the x-coordinate. So we are using these ratios to define sine, cosine, and tangent for angles that are not angles in a right triangle. Now I want to just make some observations here. The biggest surprise is that now sometimes these values will come out to be negative. So in this picture, because my terminal side is in quadrant 2, x is actually negative, right? And in quadrant 2, y is positive. So when I divide y by r, okay, let's see, y is positive. R is always positive, and maybe we should say, you know, R is always positive. So here, y over r, positive over positive, we get a positive value. But cosine theta, which is x over r, the x-coordinate is negative. We're taking a negative and dividing by positive r, so we're actually getting a negative value. So the cosine of this angle is a negative number. The tangent, which is y over x, that's going to be a positive divided by a negative, and that turns out to be negative. The tangent of this angle is also negative. So basically the story now is that sometimes our trig function values will be negative. So sometimes sine theta, cosine theta, and tan theta will be negative. And maybe I shouldn't say sometimes, it can be quite often. So now we're ready to do some problems. And I just want to go back to that picture on the first page, because this is really the picture and this is the formulas in the box that we got to have memorized for the next portion of this course.